Okay, so for our first problem, we have cosine squared x minus sine squared x over 1 minus tangent squared x equals cosine squared x. So, one way we could solve is that we could take one of our Pythagorean identities, sine squared x plus cosine squared x equals 1, and then we can use that to convert the sine squared to all cosine, as in 1 minus cosine squared x. And we can plug that in for cosine squared x minus 1 minus cosine squared x over 1 minus tangent squared x. And then we can try to solve from there. Another way we can solve is to use one of our quotient identities, as in tangent equals sine over cosine. So we can take the tangent squared x at the bottom and turn it into sine squared x over cosine squared x, and try to solve from there as well. And then for our next problem, we have 1 minus cosine 2x equals tangent x sine 2x. So we could, to solve this, we could start with either side because they're both equally complicated. So for the first one, I decided to start with the 1 minus cosine 2x. And then, since there's a sign on the other side, I decided cosine 2 squared x equals cosine squared x minus sine squared x. For 1 minus cosine squared x minus sine squared x, and we can try to solve from there. Another method I chose was another double angle formula on the other side, as in turning the sine 2x into 2 sine x cosine x for 2 tangent x sine x cosine x. And we could try to solve from there. And then, for our last one, which is tangent x minus pi over 4 equals tangent x minus 1, tangent x plus 1. So, for this one, I started with a difference identity, as in tangent a minus b equals tan a minus tan b over 1 plus tan a tan b. So, to do that, I just plugged in as in tan x minus tan pi over 4 over 1 plus tan x tangent pi over 4. And we could try to solve from there. And then the last method, which is a little more complicated, I tried to convert the tangent x minus pi over 4 into something we could use for a cofunction identity, which means I multiplied it by 2 on both sides. And then I tried to remove the negative sign, and then which, I'm not sure if this is accurate, but it's negative cotangent 2x, which is a little more complicated, so I recommend the first method.